In this video, I'm going to be talking about the M method to work out the corresponding state of returns to scale indicated by a certain production function. So here is the idea. The idea is we are discussing whether it is doable for a firm to expand its scale. And expanding its scale is to say, originally the firm starts with a share of capital and labor, and now after expansion, this one firm now is utilizing M times of capital and M times of labor where M is greater than 1 for its production. So those are the aspects of inputs. And here we are looking at the corresponding outputs here, which is Q, MK, ML, meaning the output by using M times the K, M times the L. And here we are comparing this to firms of original scale, right? This is original scale. And this is expanded scale. So this is one big firm utilizing the inputs of expanded scale. And we are comparing that to firm of original scale, firms of original scale utilizing the original share of capital and labor, but the inputs should be the same as this one, right? So here in this case, each firm is using one share of capital, one share of labor, but here we have M numbers of firms. So in total, on the right-hand side is also M times of capital, M times of labor utilized. So we are looking at different organizations of firms. This is one big firm. This is many small firms of original size. We want to see in terms of output, which one dominates the other. So this is basically the idea of return to scale. And here, if the answer is equal, it's constant return to scale. The answer is greater, the left-hand side is greater. The one big firm utilizing the same resource can produce more output. That is increasing return to scale, because here the scale, right, has this effect in enhancing the output. And if it is reverse, it means the firm being bigger is not as good as let many firms of original size to do the work. So that is decreasing returns to scale. In the third case, the bigger scale actually becomes hindrance to its output. So those are the three scenarios. So here in the slide, class number 18, lecture number 18, on slides 9, lecture 18, slides 8 to 9, I introduced the M method to help you figure out. If you are given a production function, those are the three steps that you need to take. The first one is to figure out, the first step is to work out the original output using the original scale of inputs. So that is Q as a function of K and L, right? So then we're looking at the output of the expanded scale, which is Q as a function of MK, ML. So now that's how much you can output as one big firm. Okay. And the last step is comparison. What are we comparing? We're comparing one big firm's output to many firms of original scale, but utilizing the same output, the same input, right? And we are comparing which one is bigger. Okay, so these are the three steps. So now let's go through one example. Example is, so here I'm going through case 3 on page 12 of lecture 18. Okay, so here Q is a function of K and L, which is given to you specifically as K by square root of L. All right, let's follow the 3 steps. Step 1, what is the original output? QKL equals to K by square root of L. Just copy it down. But here, in this case, we were using one share of capital, one share of labor, so you have exactly the same as the production function itself. But now, let's look at the expanded scale, which is Q of MKML. So now, here it's in the production function, this is to say, this is the capital that you use, but how much capital you're using now? M times the K, right? And then multiply by square root of how much L that you're using, M times of L. So then it's MK by square root of M by square root of L, and let's rearrange it. That's M by square root of M by K by square root of L, and here M by square root M is M to the power of half, and here it is M to the power of 1. So the result is M to the power of 1 plus half K by square root of L, which is M 2/3 K by square root of L. Okay. And then let's look at the third one, which is to compare. Okay. Q, MK, ML comparing to M times of QKL. So the left-hand side is in step 2. According to step 2, that's M 2/3 K square root of L. And the right-hand side is M by K square root of L. But here, knowing that M is greater than 1, because we are discussing whether we should be expanding the scale or not, then in this comparison, because M 2/3, right, is with a power that is greater than 1, that should be greater than M to the power of 1, since M is greater than 1. Okay, so that's this M method. And here, if you look at this, right, if you are given a certain number, so then if it is a practical question, if say scale expanded by 20%, right, then it's asking you how much output will change. For this type of question, how do you solve it? Well, M expanded by 20%, that a scale expanded by 20%, that means you're using the original share plus 20% of capital, which is 1.2 times of capital, right? And it works the same for labor. Labor plus 20% of labor, which is 1.2 times of labor. In that case, M equal to 1.2. Right? For this firm, with this production function, that is K by square root of L. And here, according to step 2, what do you have? You have Q MK ML equals to M 2/3 K by square root of L. But here, if you compare that to step 1, that is exactly m 2/3 power of 2/3 by q of k and l, right? Then you just need to plug it in. So here, if m equals to 1.2, according to this question, then q 1.2k 1.2l should equal to 1.2 to the power of 2/3, right? Multiplied by q k l. So I just need to use a little bit of calculator to calculate this. 1.2 to the power of 2/3. That is, to use scientific calculator. 1.2 to the power of 2/3. That equals to 1.315, okay, QKL. So here it tells you now with the scale increased by 1.2 times in both capital and labor, when the scale increased to 1.2 times, right, of the original capital and labor, now your output will increase to 1.315 times of our original output, which means output increases by how much? By 31.5%. So the entire thing tells you different variations of the M method and returns to scale. Thank you.